OK, today's topic is x86 assembly and call stack. I hope you're excited. So these are the security principles from last time. I won't read them out loud, but remember that these are the things that we keep in mind as we go through the class. So the first half of today is going to be mostly review from CS61C. We'll think about how computers represent the code and the data that we're trying to store. And then in the second half, we'll cover some new content using an assembly language that you might not have seen before called x86. And in particular, we'll focus on how you call a function in x86. So that's the plan for today. So the first thing we have to go through is number representation. So hopefully from CS61C or some other prerequisite class that you've taken, you remember that all data is ultimately represented as bits. It doesn't matter if you're representing a number or a picture or a string. Everything is ultimately represented as ones or zeros. And just like how when you're measuring, say, distance, there's different units of measurement. There's meter, there's kilometer, there's centimeter. Well, just like that, there are also different ways to measure the number of bits. So a single binary digit, we call that a bit. And if you have a group of 8 bits, we call that a byte. So for example, this particular bit string has 16 bits. And equivalently, we say it has 2 bytes. Those are just 2 different ways to measure the same number of bits. OK. So we could just go ahead and write out all of the bits with zeros and ones. But writing a lot of zeros and ones is going to get very ugly very quickly. So we invented a shorthand, which is instead of writing 4 binary digits, we can actually condense them into a single hexadecimal digit. And remember, hexadecimal is base 16. So there are 16 digits ranging from 0 all the way to F. So what we do is we take every 4-digit bit string, and we map it to a unique hexadecimal digit. And the only reason we're doing this is just because I don't want to have to represent long binary strings as a bunch of ones and zeros. By writing them in hex, I get slightly easier to read numbers, and that's good for us. So for example, I could write out some piece of data that I'm trying to store. It could be a number. It could be a character. I could write it like this, but that's a lot of ones and zeros, and I don't want to read that. So instead, what I can do is I can take the first 4 bits. I look it up in my table. OK, 1100 is C. And then 0110, OK, I look that up in my table. Where are you? That's 6. So this can be written as 0xC6. It's just shorthand. For clarity, if we're writing in base 2, we use 0b. If we're writing in base 16 or hexadecimal, we use 0x. But all that this is shorthand.